Okay, hello students. Let us take on an application of this double integration. Uh, Already I have told you that double integration means volume of a region which is between a function and a region. But if we do not take any function, okay, then the double integration can be used to find out area which is trapped between two curves. Okay, so for example, if I just take double integration over r dx dy, okay, now here you note that there is no function inside this integration, only we are integrating over the region dx dy. Okay, this gives you me the area of the region. Okay, this gives me the area of the region, right? So this we can use to get area of certain region. Maybe that is represented in Cartesian form or maybe in polar form, right? Okay, so now this region, so in Cartesian form, what is our formula? Cartesian form. Okay, so when the region is represented in Cartesian form, now it is like you are going from x equal to a to b and y equal to some function of x to some function of, so these are two curves f1x to f2x. Okay, and then inner integration is with respect to x and then y, dy dx, right? Or this can be written as integral x equal to f1y to x equal to f2y and y is equal to say c to d of dx dy. Okay, so both these formula can be used to find out the area which is trapped in this region. Okay, so from this curve to this curve, between this limit to this limit. Now geometrically how you can show this? So geometrically we can show like this. Okay, suppose this is a curve, say f1x, and this is another curve, say f2x, right? And now see that this is say uh, x equal to a to x equal to b, so we can find out this area. Okay, we can find out this area, right? So this is possible now. Okay, so one of the application of this definite integration is to get a area which is between the two region. Remember here the integrand is absent. Okay, it is one only, and only dx dy you have to take inside the integration. Okay, let us take one example of this. Okay, so we'll take an example. It is given that find area bounded by, find area bounded by y is equal to y square equal to 4ax and x square equal to 4ay. So this is basically two parabolas, and within that whatever the area is trapped we need to find out. So let us draw this. Okay, so to draw this, see that y square equal to 4ax is this. This is y square equal to 4ax and x square equal to 4ay is this. Okay, so the area trapped between these two curves is this one. So we need to find out what is this area is. Okay, with the area of this particular part. So this is our region. This is our region. Okay. Now before we proceed, what we require is to find out these points of intersection. Okay. Obviously this point is the origin, right? So we will find out this point, okay, and that is by using these two equations. Okay, so one equation I'll try to put in the other one and we'll find out those points. Okay, so I'll say from equation y square equal to 4ax and x square equal to 4ay. Okay, what we can write is okay, let me square this. So this is y raised to 4 is equal to 16a square x square. Okay, I squared, and then now x square I'll substitute by 4ay. So y raised to 4 is equal to 16a square into 4ay, right? So this is equal to y raised to 4 equal to 64a cube y. Right? Okay. So if I take this to this side, it is y raised to 4 minus 64 a cube y equal to 0. So y into bracket y cube minus 64 a cube is equal to 0. So the values are y equal to 0 and y is equal to 4a. Okay, and there are some more values, but we are interested in these values. So if I put these values here in this one of this equation, I'll get x equal to 0. So that is the origin, that is one intersection point. And if I put it here, it will be 4a. Okay, so this point is 4a by 4e. I call this as e. Got it? Okay, so now we are finding the area in this region. Okay, what I'll do is I'll keep my pen like this to traverse this area. And now see that I'm keeping my pen parallel to y-axis. Okay, this is parallel to y-axis, right? So the inner integration I'm going to do with y first, and then with respect to x. Okay, so how I'll get my limits? So the area will be equal to I'll put the integrations over here. Now see, to the lower end, it intersects this equation, and it is so. If I just mount my pen like this, to the lower end, it intersects what? It intersects y equal to x square by 4a. So I just shifted the terms. And to the upper end, it intersects y is equal to under root 4x. Right? Okay. So I'll put these limits over here. So x square by 4a to under root 4ax. And then I slide this pen to cover this region. So it's from 0 to 4e. So 0 to 4. Okay. Right? Fine. And then now inner integration is with respect to y and then with respect to x. So we will have 0 to 4a integral dy is simple y from x square by 4a to root 4ax dx. So it is 0 to 4a. Okay, this will be root 4ax minus x square by 4a dx. Right? And now if we separate this, what we will get is, okay, so let us separate this. So we have, this is further equal to integral 0 to 4a. Now I'll take this as 2 root a x raised to half dx. Okay, minus 1 by 4a integral 0 to 4a x square dx. Fine. So we have separated the two integrations. Okay, now let us solve them. So this is equal to 2 root a into, now this is x raised to half plus 1, so 3 by 2 upon 3 by 2. So x raised to 3 by 2 upon 3 by 2 from 0 to 4a minus 1 by 4a into x cubed by 3 from 0 to 4. Right? So further, this can be written as so this is equal to further 4 by 3 root a, okay, and 4a raised to 3 by 2 into 4a raised to 3 by 2, okay, minus 1 by 4, so 1 by 12a, right? Okay, and 4a cube, so it is 64a cube. Okay, so if I simplify this further, now see that this is 2 square, so 2 cube is 8, 8 into 4 is 32 by 3, and this is uh, half, so a square, okay, minus 64 by 12, so it is 16 by 3 a square, okay, and when I solve this is 16 by 3. So this is the area of that region that we have drawn, okay. So that area, so let me just get a picture over here. See, this was the area, okay, and this area is now 16 by 3 a square. Fine. So this way you can use the double integration to find out the area between two curves. Okay, fine. So try to solve some more problems from the exercise.